Hey, this is Mr. Ayton. This is differentiation or derivatives. And whether you're in calculus or pre-calculus, we're continuing on with the power rule. And we're going to next step on the power rule. We're going to manipulate a function before we differentiate it. So if you haven't watched my power rule video, make sure you look at the power rule for calculus. So here we go. The first rule of manipulating a function before you go to derive it. Here I have a function. We have x squared plus x minus 6. It doesn't look that simple, but we can factor it. So let's try to factor this function here. And so when I factor it, I'm going to factor that numerator to, we have x squared, which is going to be x and x. We have, what are the factors of 6? Are 3 and 2, which means we're going to be plus 3 minus 2 to give you that middle number of positive 1x. You can see on the denominator we have x minus 2. And what has canceled out? We have a discontinuous graph right here at x is equal to 2, which means my function f of x is equal to x plus 3. Now we can do the derivative of that using the power rule. So what's a derivative of 1x to the first power is just 1. What's the derivative of 3 is 0. And that is my derivative of this function, is f prime of x is equal to 1. So you may have to try to factor. Okay, so if you can see it, if it's factorable, we're going to factor and then apply the power rule. We could also divide. You can see how here we have x squared minus 3x plus 7 divided by x. So x is going to be a denominator for each thing. So we have x squared over x, that's our common denominator, 3x over x, plus 7 over x, okay? And so we can see we have x squared over x is just x, minus 3, because the x's cancel out, plus 7x to the negative 1 power. 7x to the negative 1 power. Now we can apply our power rule here. So the power rule, what's the derivative of x is 1. What's the derivative of negative 3? It's 0. We're going to apply the power rule, so we're going to multiply this out. We get negative 7x to the negative 2. And we could rearrange it if we wanted of saying 1 minus 7 over x squared. Okay, and so that is the derivative of my function. Okay, and so I had to just do a little dividing before I began. Now you can see this little thing that we did right here of 7 over x, and we made that into x to the negative 7x to the negative 1 power. We're going to see that in just a second. We can also take a look at radicals. Okay, so we take y equals, what is the square root of x? It's really x to the 1/2 power. So you can see how we manipulated it. We kind of rearranged it. And so now we can apply my power rule. Okay, we're going to multiply that 1/2. So we have 1/2 x. We're going to subtract 1 from 1/2. That leaves me with negative 1/2. And I can rearrange that guy into 1 over 2. And what is x to the negative 1/2? It's the square root of x on the denominator right there. And you can see, what did I do? I rearranged it to make me able to apply the power rule. Once I applied the power rule, I was able to rearrange it and simplify it a little bit further. Here's those negative exponents, what we just talked about. So we have 1 over x to the 3rd power, which is really x to the negative 3 power. So if you see a denominator, an exponent on the denominator, make that into a negative exponent. It makes the power rule very, very easy then. We multiply by negative 3. We get negative 3x to the negative 4 because it brings it down. Let's rearrange that back to the beginning. We have a 3 on the numerator, x to the negative 4, which means x to the 4th on our denominator. And that is my derivative using negative exponents. We could also have mixed company. Okay, you can see how here I have a radical. He's on the denominator, so he's not only a negative exponent, he is also a radical. And you can see I'm going to divide that into the top function. And so you can see this is kind of what I call mixed company, because what we have here is we have a common denominator. We're going to kind of try to simplify him out. So we have x squared, and we have x to the 1/2 power there, plus 3x, x to the 1/2 power, minus 2 over x to the 1/2 power. All right. So let's do a little bit of simplification. So remember, what do we do with exponents when we're dividing? We subtract those exponents. So we have x squared, 2 minus 1/2 leaves me with 3/2, doesn't it? So we have x to the 3/2 power. Here we have 1 minus 1/2, that leaves me with 1/2 when I subtract those, minus 2 times x to the negative 1/2 because he's on the denominator right there. Now I can apply my power rule, can I? We're going to multiply out. We get 3/2 x to 3/2 minus 1 leaves me with 1/2. Okay, plus 3 times 1/2, that's 3/2. X to the 1/2 minus 1 is negative 1/2. Minus, I'm going to multiply the negative 1/2 over, that leaves me with positive 1x, and negative 1/2 minus 1 is negative 3/2. Okay, now I'm fine if you leave it like that. We can clean it up a little bit. So if I clean it up, 3, and we have x to the 1/2, that's the square root of x over 2. Okay, plus, you can see 3 on the numerator, and 2, and the x to the negative 1/2, that means he's the square root of x on the bottom, on the denominator, plus 1 over, this is the negative 3/2 power, so negative means it's on the denominator, to the 1/2 power is like a root, and that is x cubed on that, or x to the 3/2 power on the denominator right there. And so you can see that is the most cleaned up version. Now obviously I could get common denominators on that. I don't really have to, and so I'm just looking for the derivative. And so this was differentiation. Make sure if you have to, if you can't apply the power rule right away, look to see if you can do a few different things. See if it's a radical, see if it's on the denominator, which is a negative exponent, see if it can be factored, or maybe even divided out. So manipulate it, apply that power rule, clean it up if you have to at the end, call it a day. That is differentiation.